Good morning, sir. This is DNS Kaushik, 19BC 1363. Today I am going to explain about SHA-512 algorithm. This is the overall working of SHA-512 algorithm. Let's go and discuss about it in detail. First, we need to add some parity bits to the given message, and we should leave exactly 128 bits at the last, so that when we add these 128 bits, the overall length of the message should be the multiple of 1024 bits. And here you can clearly see that for the given message, we are adding some padding bits and we are leaving exactly 128 bits further. And these padding bits we are adding, and the first bit will be the 1 and the all 0 will be followed by the next till the end. After doing this, we need to find the remaining left 128 bits, and we calculate the rest remaining 128 bits by using modulo with 2 power 64. And after once we are done with it, the total length of the message will become multiple of 1024 bits. And after that, we will use some already initialized registers with the given values that are mentioned here. And these are the default values, and these are the default k values. These both things we will be using in the compression function, and this is the compression function. Here you can clearly see that there is a one message scheduler, and there are some 80 rounds, and here each round takes input from the previous round, and the round 0 takes W0, that is watt 0, and K0 values and previous hash value as input. And after taking these inputs, after performing some operations, this will update the buffers that are present, and this buffers output is given as input to the next round. And like this, it happens for the 80 rounds. And you can clearly see that in the last round, after we are getting the final buffer values, the previous hash value, that is SHA-512 is added to it, and we perform modulo operation here, and we will get the HA value, and this HA value will be given to the another block, and this continues for the n number of blocks. And here to calculate the watts, we use the below formula, that is W of t equal to sigma power 1 of W power t minus 2 plus W power t minus 7 plus sigma power 0 of W power t minus 15 plus W power t minus 16, where sigma power 0 of x is equal to ROTR of 1 of x. It means that circular right rotation of x by n bits. Here n is equal to 1, so we will do circular rotation of x by 1 bit. And likewise, we will do the others. And here you can see that SHR is nothing but circular right shift of x by n bits. Here SHR of 7 of x means we should do circular right shift of x by 7 bits, and sigma power 1 of x is calculated by using this formula. And we calculate the watts like this. First, we can easily calculate the watts from W0 to W15 by using the above mentioned formula. But from watt 16 to 79, we'll calculate these values by using the watt 0 to 15, and there will be several combinations And you can clearly see that from the message we are calculating the watt 0 to watt 15, and from watt 16 we are using the previous watt values, and there are some combination of these watt values, and we'll perform some operation like sigma operation and XOR operation, and finally we'll get W16, and like this we will do for all the watts till W79, and this operation is done by the formulas that were present here. And now coming to round function, here you can clearly see that there are 8 registers, and the output of A is given to B as input, and B is given to C as input, and C is given for D as input, and E is given to F as input, and F is given as input to G, and G is given as H. Here you can clearly notice that for A and E, the inputs are D plus T1, and for A, it is T1 plus T2. These two are exceptions, and this T1 and T2 values can be calculated by using this formula. T1 is equal to H plus CH of E comma F comma G plus sigma of 1 to 512 of E plus WT plus KT plus, to find the T2 value, we use the formula sigma of 0 to 512 of A plus majority function of ABC. And after this, these are the functions that we use to calculate the round function values. Here you can see that CH of E comma F comma G is equal to E and F XOR operation, not E and G, and majority function A comma C, A comma B comma C equal to A and B XOR operation, A and C XOR operation, B and C. And to find sigma of A, we'll use ROTR of A comma 28 XOR operation, again ROTR of A comma 34, again XOR operation, again ROTR of A comma 39. And for sigma of E, we use the formula ROTR E comma 14 XOR operation, ROTR E comma 18 XOR operation, ROTR E comma 41. Here plus is equal to additional modulo 2 power 64, and K is nothing but a 64 additive constant, and W is the watt that we are currently deriving from 512-bit input block. And by using this function, we calculate these buffer values, and these buffer values are keep on updating from round 0 to round 79, that is total 80 rounds. And when the 80 rounds is completed, the output of one block will be given as input of to next block, and the output obtained for the last round of last message block is the hash code of the entire message. This is the overall working of SHA-512 algorithm, and here you can clearly see that in short, a message will be given. We add some padding bits to it, and we'll exactly leave 128 bits, and these 128 bits will be calculated by modulo operation 2 power 64, and after adding this all these bits, the total number of bits will be become n 1024 multiple of bits, and this will be divided into some n blocks. Each block contains 1024 bits, that is message 1 and message 2 and so on to message m. And this initial vector values, that is h of 0, and this message value will be given as input to a compression function, and this compression function output plus the initial hash value After combining these two, we'll get the new hash value, and we'll repeat this process for the all n blocks, and finally we'll get the output hash code. So this is what, in short, I explained SHA-512 algorithm. Thank you.